Good morning, bonjour. We're thrilled to join you live from the Canadian Space Agency headquarters on the south shore of Montreal. I'm Sarah Gallagher, Science Advisor to the CSA President and astrophysicist at Western University.
And I'm Nathalie Ouellette, the Outreach Scientist for the Webb Telescope in Canada and the Coordinator for the Institute for Research on Exoplanets at the Université de Montréal. Today, we're so thrilled and excited to unveil Webb's first in-depth look at an exoplanet and its atmosphere.
Canada's contributions to this epic adventure included two critical elements. The first is the Fine Guidance Sensor, which enables the exquisite images that you are seeing today. There is a highly precise pair of cameras that lock onto guide stars while the telescope is in motion and keep those images rock solid so we can have the beautiful images from that beautiful mirror. And the second is the NIRISS, which collects infrared light. NIRISS can observe from early galaxies, just like you've just seen, to exoplanets, which are worlds that orbit stars beyond our solar system.
But to understand how NIRISS collects this information, it's important to understand a key technique called spectroscopy. Essentially, researchers use spectroscopy to break apart light into individual colors or wavelengths in order to study celestial objects in greater detail. And for exoplanets, we use a method called transit spectroscopy to unveil hidden details about these faraway worlds and their atmospheres. But how does transit spectroscopy work?
So, atmospheric transmission spectroscopy happens when you have a star like our sun, and the planet, the exoplanet, passes in front of it. The light from that star can pass through the atmosphere, and all of the molecules in that atmosphere can leave signatures on the light. And so that allows us to look for things like biosignatures or the signatures of life around other worlds.
That's so exciting, and this is definitely why exoplanet research is one of the most exciting fields in astronomy today. Over the last few decades, survey telescopes like TESS and Kepler have discovered and cataloged over 5,000 exoplanets in our galaxy alone, and that's just the tip of the iceberg. Now, Webb is set to rewrite astronomy textbooks. International teams of scientists from all over the world will be able to zoom in on interesting alien worlds and take a closer than ever before look at their hidden details and their atmospheres. The search for life elsewhere in the universe is definitely on, and Webb is an incredible new ally in this search.
So now for the big reveal. NIRISS has found definitive evidence for water in a hot gas giant exoplanet's atmosphere. That exoplanet is called WASP-96b. It's about 1,150 light years away from Earth. And this is the most detailed near-infrared transmission spectrum of an exoplanet atmosphere that has ever been captured. Each white dot on this graph represents a data point that shows how much light was absorbed by the planet's atmosphere. All of those bumps and wiggles are signatures. They carry information about what the molecules are in the atmosphere of that exoplanet. And we can see from this beautiful data that there's water in the atmosphere. And also there's evidence for haze and clouds, which couldn't be seen before. This is incredible work. C'est incroyable!
Je suis d'accord. C'est incroyable. I have to say, looking at this data, how clean and sharp it is really amazing, but Webb is only getting started. WASP-96b as an exoplanet is hot, puffy, a gas giant that orbits very close to its sun-like star, and that makes it relatively easy to spot. But Webb and NIRISS will have the capability to look at much smaller planets.
Nathalie, what's next? What can we expect?
So ultimately, in the field of exoplanet research, the holy grail is finding an Earth 2.0. That is a rocky exoplanet with an atmosphere that contains interesting elements and molecules that is just at the right distance from its star to have a temperature similar to Earth's. And that region, just at the right distance from a star, is called the habitable zone, or the Goldilocks zone, because the temperature there is just right for water to remain liquid and potentially support life. And we know that water is essential for life as we know it here on Earth. So the fact that NIRISS and Webb can detect water is a huge step forward in the search for alien life. But exoplanets and their host stars are incredibly diverse, and every single planetary system that Webb observes brings us closer to a deeper understanding of how these faraway worlds and even our own solar system form and evolve.
Webb and its new observations and these beautiful instruments are opening a new world for researchers and our young astronomers in Canada and around the world. A massive thank you to our partners NASA and the European Space Agency, and we can't wait to see what's next. Go Webb, go!